Oftentimes, an initial plus change equals final problem will be given two quantities, and we'll have to solve for the third. So here what I'm going to do is I'm going to solve it with a formula, and we want the vector diagram to agree with the formula. They gave us the initial position and the final position. So let's do the drawing first. We want to start off at 0, and let's go to the right 3 units. According to this, that's going to be our xi. And they also tell us the xf. Now, xi and xf have to start from 0. But the xf is in the negative direction, which means we'll actually start here and we'll go to the left 6 units, and we'll label that as xf. So they're asking us to find the displacement delta x. As was shown in a previous video, the displacement represents walking from the initial position to the final position. So I don't even have to use the formula in order to complete the diagram. This is going to be my displacement. But let's just confirm that that's correct by using the formula. And in the formula, we want initial plus change equals final. You don't always have to write it out in words, of course. We want it in symbols. xi plus delta x equals xf. Now, in order to keep things concise and use less symbols, I'm not going to write them in their vector form. I'll just remove the i's from the quantities. So we'll have 3 meters plus delta x equals negative 6 meters. Just simpler that way. Now we'll solve for delta x by subtracting 3 meters on both sides. This reveals that our delta x is negative 9 meters. Is that in agreement with the picture? And the answer is yes, because the length of the arrow is 9, and also it's pointing to the left, which agrees with the sign of our findings there. So it all tells the same story, and that's what we want.